Hi folks, good morning, good afternoon, good day, wherever you are. Welcome to our webinar on using WireShark. My name is Dan Klimke. I'm the Director of Product Marketing at NetAlly. And I'm happy that you've joined us for this part two. I don't know if all of you attended part one, but that webinar is available. I'll post a link to that in our chat window so that you guys can go back to it if you hadn't seen it, or if you want to review what Chris went over in the last session, which was a kind of a deep dive on DNS and how to set up a profile in WireShark. Today we're digging into part two. So this is going to be about TCP analysis. And as a note of that, let me switch over here to this screen, and I am going to send over in the chat window a link to this this site. This is CloudShark. I don't know if you're all familiar with CloudShark. Chris will talk about that briefly. But if you want to follow along with the trace file that Chris is going to be going over today, you can use that link to access that trace file in CloudShark. If you want to analyze this trace file in WireShark as we go along, simply go to that link, click on the export window here in the upper right and click download file, and that'll load that PCAP file down to your desktop so that you can follow along. All right, so the link is in the chat window. Feel free to go there and grab that trace file if you like, and Chris will get into that momentarily. So just a little bit of a commercial message. You know, NetAlly is happy to bring this kind of educational content to our customers and followers, but I also want to get in a little bit of a plug for our tools. Just want to mention that we had a big announcement last week. That is the network topology mapping capability using EtherScope and our Link Live Cloud service. How this works is that the EtherScope, or a LinkRunner 10G with discovery enabled through AllyCare, will discover your network, and then that information can be uploaded into the Link Live Cloud service where you can, let's see if I can hop over here, where you can interact with that data in Link Live, automatically maps out all of your network connections. Anything that has a problem or error is going to be color coded, so you can drill into problems remotely through your map interface. And then this map is also exportable to Visio from Link Live. So another great way to understand your network and document your network. And just another mention, if you've been following up,
Hey, Dan, if you can hear me, I think, Dan, I lost your audio. Dan lost audio. Can someone put out?
And I'm going to turn the presentation over to Chris Greer. Chris, his own company is called Packet Pioneer. He does packet analysis consulting. So in as much as we want to help educate you so that you can do some of your own analysis, if you're crunched for time or running into a problem that you're having difficulty solving, Chris is available for doing remote consulting and analysis. He's a WireShark University instructor. He's got a fantastic YouTube channel with, I think, over 20,000 followers now. Chris, is that right?
Yeah, we got a lot of packet people out there. That's great.
Lots of packet people. So feel free to look up his WireShark YouTube channel. Lots of great sessions on there about how to use WireShark. Chris is a former coworker, worked with us back when we were in our Fluke Networks days, did a stint at Network Protocol Specialists, and now he's on his own. So Chris, without further ado, I'm going to make you the presenter. And okay. Along the way, folks, if you have any sort of question, you can feel free to enter that into the chat window, or into the question window. And I will attempt to answer them if I can, or I will mention the question to Chris. I'll just kind of moderate that, Chris, as we go along. So
that's it.
Without further ado, you've got the screen.
Fantastic. Thanks, Dan. Can you guys see my screen? Hopefully, Dan,
yes.
You see that okay? And I'm coming in
Yep,
okay as far as the audio goes.
you got it.
All right, thumbs up. Well, there's only one thing to do, packet people, and that is to dig into packets and have fun, because if you're not having fun looking into packets, well, then you're not hanging out with me. See, because we make packets fun. Anyway, just wanted to show you guys here on my YouTube channel, like Dan had mentioned, this is something that I like to keep as updated as possible. I throw out tips and tricks and little stuff that I find as I'm digging through traces, and I like to get it out there to the world to share it. So definitely stop by, like, subscribe, share, do all the above, because, you know, again, packets should be fun, and so is WireShark. Also, if you go to the wireshark.org page, just to keep in touch with me, even to continue to interact and get some training even beyond this webinar or even the workshop we're going to tell you about a little later, just to plug that. If you go to wireshark.org, anytime you update Wireshark, go in there and take a look at other resources. If you come down to Learn Wireshark, well, then you can see some of my training here. So here's some on-demand network training. So you can click that and you can go out to Pluralsight, and that'll help you to stream that on demand, or you can look at that training whenever it is that you have a few minutes. Or if you'd like to join me in a virtual classroom where we actually go through real live examples and get hands-on with Wireshark, and that's a 2-day course, and we dig into the guts of it and really get an understanding of how things work. So what I'm going to actually do for you today, and we started this last week, what we're going to do is look into one of the lab examples that I use in that course. So we're going to give you just a little sample. So I'm going to show you how we can use a trace file live together and dig into it and make sure you get some hands-on. So I just wanted to share that resource with you as well, so you can check that out later. Now, like Dan mentioned, on CloudShark, there's our trace file. For those of you that just joined or joined since he said it, the link is in the chat as well. If you don't see that, then let us know and we'll get that out to you. You can go out here to our trace, and again, like Dan had mentioned, you can go to export download file, or if you'd like to, you can just keep doing this on CloudShark. Why? Because it's WireShark in the cloud. Got it? Sweet, right? So these guys are some good people out there at CloudShark, and it allows us to easily collaborate as we're doing trace file analysis. So cool stuff. All right, without further ado, let's get into this. So last week, as Dan mentioned, we talked about how to build a DNS profile, how to look for slow DNS responses, how to measure those DNS responses, look at things like IPTTL and see how far away a DNS server is. Well, the reason why we did that is because DNS is an important service. If DNS is slow, the app is going to look slow. So we can't resolve names to IPs or IPv6 addresses, then we can't then begin to talk to the servers that actually have the data that we're interested in. So with that, we showed how to make sure that DNS is working properly and to quickly test it. Well, now we're going to go into the next step. Now imagine that we have an application that's still using TCP, as many do, starting to see a little shift over to UDP-based transfer, but that's for another webinar. But in this case, still we have a lot of TCP-based conversations out there. So TCP is something that we really want to make sure we understand thoroughly. Now, because you're on this webinar and you're interested in packets and you have WireShark, you're looking at it right now with me, TCP is a massively important thing for network engineers to understand. And why? Well, TCP carries important data. And a lot of times what you're going to see is that when there is an issue at TCP, or if we see an issue that TCP is complaining about, for example, retransmissions and dupacks, TCP is telling us, hey, there's packet loss, I had to resend something. A good understanding of TCP can help to steer us into the proper domain that's really causing the issue. That's why it's so important to understand. But the thing about TCP is, in a lot of environments, network engineers go, TCP, that's part of a stack on a system that I don't control. That's the server or the client. I'm responsible for the packets that go on the network. That's true. However, grabbing, owning, and understanding that traffic, especially when it comes to this protocol, will help you be a better network engineer. So that's why we're going to spend, and beyond this, it's important to thoroughly understand this protocol. So to start to learn this protocol, the first thing we're going to do is understand how the handshake works and what indicators in the handshake can help us understand more about the connection. All right. So I'm going to show you guys a little trick. Here you got the trace file, right? You can make sure that you're on the same exact packet as me. If you look on the lower right, you can see here I've got 12,000 packets, 12,000 displayed. I don't have a display filter. So if you have 12,000 bytes or 12,000 packets you're looking at as well, we're on the same exact trace. Things are looking good. Now, something that I do, little eggs that I hide in the trace file for you in these labs, you can find the questions that will lead you through the lab, and you can actually get ahead of me if you'd like. If you have some WireShark experience and you'd like to just go off on your own for a few minutes, you can do that, or you can follow along with me. All we got to do is go up to the properties, and we're going to go to statistics, capture file properties. So go ahead and go there in your menu options. And what we're going to do under capture file properties, what this does in WireShark is it gives us an overall view, and mine, of course, opened up on the wrong monitor. So it gives us this kind of metadata, if you will, about the trace file, shows us what kind of system captured it. Here you can see this is a Mac OS that captured it, what build it was. You can see the processor and the horsepower of the capture device. You can also see exactly at what time this trace file was captured. Down here, we can get a bit more information. We can see packets per second, time span, how bytes, average bits per second. That's really useful. If you can get a capture of an application, you can get a good, just a quick high level idea of how much bits per second you're actually using. So what's your throughput rate? But more importantly, if we come down to the capture file comments on the bottom, this is where the questions are for this lab. So if you do have some WireShark experience, go to town, start answering these questions. See if you can set some of these filters on your own as I walk through and show you how to do it here. If you're new to WireShark, if this is something you haven't done much of, don't worry, that's why I'm here. We're going to talk through it and we're going to have some fun. But in these labs, you're going to see that you have these different questions that will then guide you through. Okay. So I'm going to use these questions as a basis to help you to understand what's going on in this trace file. All right, so let's go ahead and take a look at the first one. Now, the first question, and you can follow right along with me, it says, let's select the first TCP SYN packet you see. Okay, so right away, if I look at my stuff here, I'm actually going to remove one of these columns, just pull this guy off just for a sec. And also this one too, just to tidy up my screen for you just a little bit. I was goofing around before I started presenting. As you can see in my screen layout here, I've got my time column, delta column, showed you how to set that up last week. We talked about a delta column, source, destination IP, protocol, TCP segment length, and then information. Now, again, first TCP SYN that is in this trace file. There's a few ways that I can do this. If you notice in the notes, one of the things that I say, your way or the highway. There's like 5 ways that we could do this. So some are a little more direct than others, but which one works for you, right? Some people would go, oh, Chris, I want to find the first SYN. Okay, let me just scroll until I see, oh, good, green, SYN. See, that's why I color my SYNs green, because they pop out at me. We learned how to set a basic coloring rule last week. We're going to do this together right now because I'm just such a believer in making your SYNs pop out at you that it's an important thing to make sure that we understand how to configure in WireShark. All right, so I'm on packet 107, but let me show you another way that we could have found this packet before we get to the coloring rule. I'm going to go up here to apply display filter, and what we're going to do is we're going to type in TCP flags SYN equals 1. Now, cool thing about WireShark, when I get it right on a display filter, it paints it green. So now I know that I got that syntax right. If I was missing an equals, if I spelled SYN wrong, then it's going to tell me, hey, you got this wrong. Let's make sure that we got it right. So equals 1. Now the thing is this tells me any packet or any TCP segment that has that TCP header in it, it goes down to the flags part of that header and it looks for the SYN bit. If the SYN bit is set, well then show packet. Now, I'm going to see the SYN not just in the outgoing SYN synchronized from the client to the server. I'm also going to see it in the SYN ACK. So if I come over here in the info, you can see I've got 2 SYNs that went out, and oh look, I got a SYN ACK too. Now for me, I like to see that because if I want to see a SYN going out, SYN coming back, I want both of those to be nice and bright Seahawks green. Sorry for the Seahawks haters, and great for the Seahawks lovers. But that's our color scheme. Again, for me, that's what I like to see. Now for you, what color do you want to paint it? Well, your way or the highway. If you like sky blue or jet black or any of it, you can do that. Now, to do so, I'm gonna go ahead and go up to view, and I'm gonna come down to coloring rules. All right, let's pause there for a second, just let you guys catch up to me. Gonna go view coloring rules. Why? I want SYNs to jump out at me. So I'm gonna come over to my coloring rules, and I'm just gonna put this out here for you so you can see what I did. You go ahead and hit plus. That'll create a new coloring rule. Then I can just name it whatever, but this is my TCP SYNs coloring rule. And the filter that I'm going to use is exactly the same as the one that we just used as a display filter. TCP.flags.syn equals 1. Now, importantly, you need to take that as soon as you create that coloring rule. It's important to drag it. You just click and drag down below bad TCP. Now, there's a reason for that. Basically, the highest priority coloring rules are on top. As we go down in priority. So let's say, for example, I had a TCP SYN that was lost, and I had to retransmit that SYN. Well, in that case, I wouldn't want to see 2 green SYNs. I would want the first one to be green, and the second one, since it's a retransmission, I would want that retransmission coloring rule to take place. So that's why I'm going to give bad TCP is going to have a higher priority than TCP SYNs. That's why we drag it down beneath that. All right. So we'll go ahead and do that, and then we're going to say OK. And here we go. So now everybody should have greens. Oh, I'm sorry, I didn't show you how to actually color it green. So I'm going to go back to view coloring rules. So once you create that rule, that's where you can go foreground and background. So what I did is I just clicked background, and I just went up and clicked a bright green part. Again, pick a color, doesn't matter. Some people have color sensitivity things, and they're like, oh, that's way too bright. I'd like to, soft yellow, or pick one. Anything that makes that jump out to you. So now I can see that first SYN, and I can see I have several different SYNs. In fact, to make sure that you're on the same physical packet as me, if we look down to displayed here in the lower right, displayed shows 197 SYNs. So that means this is a sinful trace file. It's got lots of them. Wonderful, right? Okay, so let's go ahead and go back up to the first one we see, packet 107. What we're going to do is we're going to set a filter for this connection. Keep in mind that this is now out of context. This is all just the connection attempts that are in the trace file, or the responses to those attempts. So what I'm going to do, I'm just going to right click this one. Again, few ways we can do this. I'm going to right click, and I'm going to come down here to conversation filter and TCP. Now, if you have WireShark experience, maybe you've seen somewhere around on YouTube, or you've gone and talked to somebody and they said, oh, all you do is follow TCP stream. Well, if you did that, okay, I'm not super upset at you. It does a similar kind of thing, but I do want you to take your hand like this, and then I want you to smack your hand like that, okay? That's not how we're gonna set a TCP connection. Ow. So instead of doing that, now there's a reason. Follow TCP stream, what it does is it extracts all of the packet data, the payload, out of that stream and represents it in a screen. You see a white screen come up, and it shows you all the guts that are in that stream. All right. Now I'll demonstrate it for you. Okay, so here we have follow TCP stream. Okay, great. It did set a filter for that conversation, but it also did this where, okay, now I can see ski rentals and all this stuff at Vail Resorts and all this stuff. Okay, so usually these things are encrypted these days, a lot of times, right? You see TLS encryption, where you can see the actual encrypted stuff. Now, usually, maybe at the beginning you see a few things, but then after that, it kind of goes to a bunch of encrypted stuff. So You know what most people do, that as I've looked over their shoulders and they did follow TCP stream, what most people do, as soon as this screen comes up, they come down here to the lower right and say close. So I just lost a step, right? In some cases, it takes a lot of time for that stream data to render because there's so much in the stream. It just extracts it and puts it out to this separate screen, which is great. But then if we're just going to close it and go back to our TCP conversation, well, that's kind of an extra step, a little slower, not the best way to set a filter on that conversation. So instead of doing that, now that I've just lectured you on don't follow TCP stream, which I quickly demonstrated right after, I'm going to come down here to 107 again. I just removed that filter and I'm going to right click and I'm going to come to conversation filter TCP. So conversation filter, WireShark's now asking me, what do you want to use as a basis for the conversation? Do you want me to look at the MAC addressing? Do you want me to look at the IPs? Or do you want me to look at the TCP ports? Or if we're in a fancy F5 environment where we have an F5 shim or an F5 header within the packet, then we can also do the F5 stuff. However, I'm not going down that road. We're going to come down to TCP, and now we just set a filter for TCP. Both ways work, but this one's a faster way, right? Because we're not closing down that stream data. Side point, one other real quick way you could set a filter for a TCP stream, and I do this quite a bit, or for a TCP conversation. For a TCP conversation, I can also set a TCP port filter for the client side ephemeral port. See, 50,344. So I can come in here and I can just say up here up top, TCP.port equals this port number. Now, why does that work? Because typically the client side ephemeral high numbered port that you see, the dynamic one that the client chooses, usually that is unique in a trace file. Not always. Many times though, if I just see a connection, I'm like, ooh, I want to filter on that. One of the quickest way I can type it out is just TCP port client side ephemeral, and usually that gives me what I'm interested in. And then I can set that and make sure I'm on the right actual connection by using that right click, conversation filter, TCP. All right, cool. We just saw 5 ways to set a filter for a single TCP connection. Now, why is that so important? Well, once we filter on a TCP connection, now we can start to time it appropriately. We can start to see what things can we learn about this TCP connection. So in this case, our first 3 packets, there's our TCP 3-way handshake. Now, SYN, SYN-ACK, ACK, those are the 3 packets in the handshake that I want to be able to, I need in order to establish a connection. We're gonna go through that handshake and see what we can learn from it. So here's our SYN. Now, if you set a delta column from last week, we're gonna use that again here. The SYN-ACK comes back 141 milliseconds later. So all right, packet people, budding packet heads or seasoned packet heads, depending on your experience level, what we just did, I almost want you to do like muscle memory. You set a filter for a TCP connection, you look at the delta time between the SYN and SYN-ACK, that will tell you a lot of things. First, that gives me my initial network round trip time. Mathematically, I actually have to add this last number to my, I have to actually add those deltas to get the actual mathematical true network round trip time. But you can see 55 microseconds, meh, okay. My client and server are 141 milliseconds apart. Now, if I see SYN and a really quick SYN-ACK, okay? So SYN goes out and then it's like, boom, this thing gets thrown out there in 1 microsecond. And then I see 141 milliseconds for the final ACK, then I know my capture point was not at the client, it was out at the server. We captured server side. So if your round trip time is between SYN, SYN-ACK, your client side. If your round trip time is between SYN-ACK and ACK, then you're sitting server side as a capture point. If 141 seems like it's split between the two, like let's just say I had 70 milliseconds here and 71 milliseconds here, then I know I'm sitting in the dead middle. The SYN went out, I captured it. It was 70 milliseconds of network round trip to get to my point of capture. And then from that point of capture back to the actual client, and then the ACK back to me was 71. I have to add those two numbers together, and that gives me my total network round trip, even if I'm sitting in the dead middle capturing on a firewall. All right. So those are just some tricks. Right there, you just learned about where you were sitting when this was captured. You're sitting on or near the client, and you've got 141 milliseconds. Now, right away, people, do you like 141 milliseconds? Are you happy with that number? Does it give you sunshine and rainbows? Well, probably not. 141 milliseconds, okay, it's not like half a second, but is this going to be speedy and awesome? Yeah, probably not. Especially something we want to look for is a lot of transactions. So a lot of client to server communication. Hey, server, give me that, give me that, give me that, give me that. Because every time I say give me, I'm going to suffer that network round trip time. And then some, depending on how TCP is doing its thing. All right. Now, another thing that you can do, another eye trick that I'm going to teach you is 141 should now be a part of your eyeballs, right? Or your pegboard of truth. You're going to take 141 and go, okay, I know I got that as my network round trip time. Now I can start to scan down, just kind of scroll through just a little bit. And what I want to see is every time I see a number around that period of time, in that ballpark, if you will, then I know that I just suffered a network round trip. Okay, and I don't want to see a lot of those. Because again, 141, if I suffer 8 of those, I'm over a second. All right. So if I'm suffering hundreds of those, you just found an issue. If you see hundreds of network round trips. In fact, what we can do is we can just click and sort on delta, and we can jump down to the bottom. Taught you last week how to do that. Come up here to hit your little green, go to the last packet. Jump down here to the bottom, and I can just eyeball real quick, and I can go, oh, okay, I see 1, 2, 3, maybe 4-ish network round trips. The rest is just TCP starting to send data and get things going in flight. But hey, do you think it's awful that we're experiencing only 4 network round trips here in this connection? Probably not. If things are screen punching slow, it's probably not due to you waiting for something to come back from that server or an excessive amount of delay on that application. If it's screen punching slow at this point, we're going to go look for a bunch of really small delays that add up to greater ones. But right there, that we learned about this connection. Okay, so just to put us back in context, I want to go back up to number at the top of the column, and let's click that guy. And now we are back in context. So here's our handshake, and we can start to see things go in flight. Now, let's start to look at what you should verify in any TCP handshake that you ever see. In fact, if I come up to you on the street and I say, hey, what was the window size scale factor of that handshake? You should be able to go, oh, Chris, it was this, right? So you're going to learn that. Let's go to SYN. We're going to come down to skip over TCP. And I am getting some questions about, can we download the capture? So I think that was out the chat. If you don't mind throwing that back out there again, just for the people, the fine people out there. We're going to talk about the TCP header. So let's take, again, packet 107, so we can be on the same page. And here we can see our source port, dest port, stream index. We learned last week how WireShark likes to help us out when we're doing analysis. So anything that's in those hard brackets, you can see stream index 5, that's a WireShark thing. WireShark is saying this is the 5th TCP, or it starts at 0, so technically the 6th TCP conversation, unique conversation that I have seen in this trace file. It's a unique 4-tuple. Source IP, dest IP, source port, dest port. It's unique. So here's the 5th one. All right, TCP segment length right there. Segment length, there's no encapsulated data. This is an empty an empty SYN. It doesn't carry anything. All right. Sequence number. WireShark does us a solid here. Instead of giving us the sequence number raw number that's long and scary and big, instead of doing that, it says, you know what? You're probably a human that's doing this analysis. You don't like to start counting up from this number. You and I like to start counting from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't like saying 4,071,689,433, 4,000,000, 44, 40, 35, 36, 37, right? That's not a very efficient way to count to 10. So what WireShark does is it says, you know what, why don't I just help you out and I'll zero this guy out for you. Let me give you a relative sequence number that is relative to this connection, and anything, all the bytes that I see going in this direction, I will increment by 1 and just give you a number that starts at 0. What do you think? So as a human, I say, that's great. So my next sequence number in this direction is going to start at 1. This number is exceptionally important in TCP. I am sending this number to my link partner so they know where I am beginning my sequence count from. Sequence number is important because as TCP, I'm going to send data out. I don't really care what that data is or who sent it down to me, or really my job is to get this data from me over to him and do it efficiently. And if anything gets lost, to resend it. So what I do is as I'm sending data out to my link partner, I count that up. Every byte represents a sequence number. Okay, so if you see sequence number 10, I just sent 10 bytes. Now in this case, it's saying in the next packet in this direction, TCP is going to say sequence number 1. So in a SYN, you have something that's called a ghost byte. It's a fake byte. It's not real, true byte of data, but it's allowing my link partner to increment my sequence number by 1 and respond with an acknowledgement number of +1. What that tells me is you heard me, you're there, we're talking the same language, I send you a sequence number, you increment it by 1, sweet, we're synchronized. That's why it's called a SYN, because we're synchronizing sequence numbers. Yeah, cool, yeah. All right, header length, 44 flags. If we come down to flags, we're going to expand that out. Here we can see all of the bits and bytes about our, the bits about the byte, it's just 1 byte. But we come down here to our SYN flag is 1. That's expected. But the part I really want to drill home today is options. Let's talk about some of these TCP options, which ones matter, which ones you can kind of overlook. MSS, maximum segment size. That is informing you of how much you can send me at once in a segment. So, hey, Dan, we're connecting. Do not send me any more than 1460. That's an advertisement of my maximum segment size. They do not negotiate. They do not exchange necessarily as far as, oh, let's use this number. Instead, it's, hey, this is what I can do. Dan comes back and says, all right, this is what I can do. So even if he comes back and says 500, 536 would be the lowest he would say, then I come back and I can send him 536, even if I can receive more than that, all right? Window scale, very exceptionally important to understand. Window scale, what this does is it gives me a multiplier that after the handshake, this connection will now use to increase my TCP window. The TCP window size, this is a fixed value in the TCP header. It's only a 2-byte value, 65,535. Back when TCP was first standardized back in the day, I believe it was 1981, RC 793. And only 2 bytes were given to the window size. What that means, a TCP window, a receive window in this case, that's telling Dan, hey, I have 65,535 in my TCP receive buffer. Dan cannot send me any more than 65,535 at once. If I start acking that data and he starts getting those acks, he can then send more data. But at one time, he cannot send me more than that. So that window, though, is pretty small. Really, 65K? What if Dan was on the other side of the ocean and we had a 10 gig connection between us and 141 milliseconds of delay? If my receive window only allows him to send 65K at once, that's just like saying, hey, Dan, go send me that swimming pool. I live 10 miles away from you, but you can only send it to me 1 shot glass at a time. Teeny, right? So Dan's like, okay, well, here's part of my swimming pool. I'm gonna have to send a lot of these little blocks because Chris, really, can't you increase that window? You only have a shot glass? How about a pint glass? How about a keg? Or better yet, how about a swimming pool? So the window size scaling factor allows us to multiply the TCP receive window to be much, much, much larger. The standard, the TCP option standards allow for a receive window of up to a gig. So we can take that number, and what we do is between the two of us, I say, hey, Dan, I'm gonna tell you it's 65,535, but really multiply that number by 32, and that's my true window size. That's what you can actually use. Now, the thing is, Dan, is we're never gonna talk about this again after I just told you that. We only say it in our handshake. I never again am going to advertise my multiplication factor. Another reason why it's so important to capture the handshakes. Okay, SAC permitted. I'm not going to talk too much about SAC in this webinar. It's a big concept we don't have much time to get to, but the important thing we want to know as far as the handshake, if I advertise selective acknowledgement, which means I can selectively acknowledge data as the name implies, I send that to Dan. He has to understand the SAC option and then return back the SAC option. If Dan doesn't support SAC, I can't use it. All right, so maybe like a IoT device, or maybe a really old stack that's sitting around somewhere on a printer or some other device out there that might not understand SAC. That means we cannot use that option. That makes TCP a whole lot more efficient. Okay, fuel for a later training. Let's take a look at the other SYNAC in the opposite direction. Okay, and what my eyes are just going to jump down to, let's come down to SYNAC. Those are our flags. I'm going to come down to options. Now, maximum segment size, and I'm just going to call that this server Dan. Dan, hopefully you're okay with that. He just came back and he said 1448. That's his MSS. So now I cannot transmit any more than 1448 in one single segment, even though I support more. Not negotiated. It's just an advertisement of what he can do. He does support SAC. Sweet. That means I can use it. He can use it. Great. We're just going to be rock stars. Timestamps, it's just an echo. It's a number that I send to him and he echoes it back to me. There's a few reasons for that, much beyond what we're going to get to in this webinar, but I can only use timestamps if he uses it. So if he doesn't respond with a timestamp, then I can't either. Finally, window scale. Remember my multiplier was 32? Well, he's telling me, all right, I can do a multiplier of 128. So any number that I send you, Chris, you can multiply that thing up by 128, and that will give us our calculated window size. Okay, so we actually multiply that up. Now you're gonna notice in the handshake, WireShark does not multiply that for you. Any ensuing packets will have the multiplication factor there, and we'll see the actual true window size. But right now, while we're establishing the relationship, WireShark doesn't yet apply it. But then once we start getting into the actual guts of the conversation between these two applications, we'll start to see it. All right, so can we see how much, well then the final ACK, right? Now, sorry, let me back up one more second. Back to the SYNAC. Here we can see the acknowledgement number is 1. I sent 1 ghost byte with the ACK. It's not an actual byte. Send my SYN. When Dan increments my sequence number by 1 and responds with an acknowledgement number, +1. WireShark shows that to me. Dan responded with +1. Dan's sequence number on his end is this big scary number that starts with 1. Remember mine started with 4, like 4 billion or something like that. So he's saying, all right, here's my relative sequence number. When I come down to the third packet of the handshake, I should see sequence number 1, acknowledgement number 1. Now we are synchronized. That's the whole point of the third packet of a 3-way handshake. So now I can tell Dan, hey, I heard you. I got your sequence number. I got your options. Boy, we're ready to rock and roll. Let's exchange some data. Now something goes missing, we can count it. We can make sure to categorize it, and things are going to look good. All right, so we send out this 517. That's the number of encompass bytes in the payload. There's from client to server. We send out a client, hello. We're going to start a TLS conversation. Server comes back, and this is a big thing to understand. Again, muscle memory, your eyes should just start to do this. Is this an actual response from the server at the application level, or is this TCP just responding with an acknowledgement? This is one reason why I like to have a column here for segment length. This is the encompassed payload. You can see packet 426, 0. There's nothing in this packet. So while the client did his client hello, my server just came back and this is just an empty TCP ACK. I got that packet. This is an actual response from TLS or above, right? This is just, I got your packet, don't retransmit. If the sender does not receive this acknowledgement in a reasonable amount of time, now what is reasonable? Well, reasonable is relative to my round trip time. See, TCP is smart. TCP, when it sees these handshakes, it's also configuring itself. It's going, you know what? I got 141 milliseconds in network round trip. That's my initial round trip time. If I don't hear back within a reasonable, let's just say round trip time times 3, if I don't see a response in the 400s, it's going to retransmit this client hello. It's going to say, you know, it didn't get there. Let me retransmit it. Now, why does it pick that number or in that ballpark, right? It depends on the TCP stack. But you should see there's a retransmission timeout that starts to get adjusted at the beginning of a connection. And as I learn more, as I send data and that data is acknowledged, I start to really understand this network between me and Dan. See, TCP at the beginning doesn't know anything about the network. Do we have a second between us? Do we have 1 millisecond between us? As it starts to see data in flight, it starts to figure out, oh, Dan's not very far away from me. I can start to reduce my retransmission timer, and I can make sure that I'm efficiently retransmitting things instead of waiting forever to send a retransmission. All right, but in this case, we did see an acknowledgement go. WireShark does something kind of cool for us. You see packet 426. This is an acknowledgement of packet 262. So now you can, this is an ACK 4. All right, so 426, it's acknowledgement. What is it ACKing? The packet above. This gets nice when we start to see a lot of data going in flight and you see an acknowledgement, you wonder, what is this acknowledging? Look for the check mark. That's going to be on that upper left under the number column, and you can start to see what's going in flight. All right, so that was a quick primer about the handshake. We also answered several of the questions as we were just talking through that were in our little lab examples, right? We answered several of these as we were going. But there's a whole lot more that we can learn about this. And before we open up to questions, I still have a little bit more time here. I just want to show you a few TCP tricks that I use as I'm looking through a trace file. Now, there's nothing inherently wrong with the connection that we've been looking at so far. We can continue to go down, look at sequence and number, acknowledgement number, but I'm actually going to ask you to come to my virtual class to really get into the guts about sequence and acknowledgement number. We definitely talk about it. What I'm going to do is I'm going to remove this filter. And something that I like to do when I'm looking at a TCP conversation or looking at different issues that are in the TCP trace, I like to have a button up here called TCP flags. This is in my TCP plane profile. Showed you last week how to set up a profile, so hopefully you know how to do that. Notice the filter that was applied, tcp.analysis.flags and not TCP analysis window update. Tell you what, I'll even do Control C, and I'm going to come over here to our little chat, and let me throw this guy in the chat to everybody just to make sure everybody got this. All right, Control V, boom. Now, what does that do? It shows me all error indicators, all TCP issues that are in the trace. Things like dupacks, retransmissions, previous segment not captured, spurious retransmissions, out of orders, all kinds of stuff. And the reason why I say don't give me window updates is because unless a window goes down to 0, a window update is a pretty common thing. Maybe I have a 1 gig window and it went down to 999 megabytes and I updated it back to 1 gig again. That would be a window update. Things are still flowing, things are fine. There are times when those matter, but generally speaking, window updates, they're benign, they're okay. It just means the client is processing data out for more data to come in. Only when we see that window go really down to 0 am I concerned about the TCP receive window. Question just came in, how can I show that TCP segment length column? Great question. Pick any TCP packet, go down here to TCP segment length, right click, go up to apply as column. You got your TCP segment length column. So you can pick any TCP packet, you'll see that there, all right? Now, I want to talk about this before we end because it's huge. This is something I get asked about all the time, and that is duplex. In fact, I've got a video on it on YouTube. Go check it out. Like, share, subscribe. If you pick any of these duplex, let's just pick if you scroll down in your copy of the trace file, we have the same trace file. There's a burst of duplex on port number 5238, okay? 5238. Pick any of these packets that you see with 5238, and our duplex go up to, I think, yeah, 93 of them. We're gonna right click. See, what I do is I first want WireShark to show that to me, and then I wanna use my conversation filter to filter on just that conversation, all right? Right click, conversation filter, gonna go to TCP. So now I got a bunch of duplex. What does that mean? Well, this ACK is duplicated, yeah? Like that naming? But here's the thing. If I scroll up above this, usually what you'll see with duplex is you'll see up above it, you'll see previous segment not captured. What this means is that we were trucking along just fine. Boom, 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 boom. Previous segment not captured. What this means is that WireShark experienced a gap in the sequence number. Just as if I would counting to 10. 1, 2, 3, 4, 5, 6, 8, 9, 10. And your brain went, where was 7? You went from 6 to 8. Whoa, 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 whoa. On 8, you're gonna say, hang on a second, there was a gap. There's a missing sequence number. Either it was dropped, so, or on the way to you, the air dropped my voice, or it's possible that your point of capture never saw it. Maybe we're on a span port that was overloaded. Maybe the device that was actually doing the capturing, because we weren't capturing with an EtherScope. See? Our point of capture got overloaded. We dropped traffic at the point of capture. Sometimes that can happen too. But usually, that's the case. If I see previous segment not captured and no black lines after it, usually that was due to a poor capture method. Why? Because things just kept going just fine, right? Everything after this, there was no TCP recovery, no retransmission, no duplex. That probably means our analyzer just didn't get it. But if I see previous not captured and then recovery symptoms, which is duplex and retransmissions, well, then I know this was probably lost by the network. Now, is this a big deal? Is this something I should go troubleshoot? I'm going to show you a trick. If you look at TCP previous segment not captured, what I'd like you to do is I'd like you to come over here to our time column that is incrementing the total number of time. I'm going to right click, going to go to set unset time reference. All right. What I just did is I started a stopwatch on that packet where I saw something go missing. It's just like a start a stopwatch. Now what I'm going to do is I see all these duplex, and what duplex are doing, they are indicating down in the SAC block down below, which we don't have time to get into too much. If I go down to TCP options, the client is saying, hey, send me 7, send me 7. I got 1 to 6 and I got 8, 9, 10. I got those, but send me 7. That's the one I'm missing. That's what SAC does. So even though I'm going to keep counting though, because again, I've got 141 milliseconds between these two endpoints, right? So, or something thereabout. So I come down here, I see data still in flight from the server, but keep in mind, this is less than a millisecond after the point of loss. So the server isn't even aware yet that there's been a problem. So 11, 12, 13, 14, it just keeps counting, right? And I'm taking the huge sequence numbers and breaking it down to a very simple one, right? 11, 12, 13, 14. Client's like, great, I got 11, got 12, got 13, got 14, got 15, but yeah, 7, whenever you get around to it, if you could just send me that, that would be great. Well, I haven't heard that yet. 15, 16, 17, 18, 19, 20, 21, 22, 23. And client's like, great, I'm getting all this new stuff, but right, 777, still missing. So anyway, we're gonna scroll. So these dupacks, they're incrementing, they're large. We start to see 96 of them. Is that a big problem? Is the sky falling? Is my network being ripped apart at the seams? Do I need to call Cisco? Right here, if I come down to 93, again, we're only 4 milliseconds in. Right, so I had 93 dupacks in only 4 milliseconds. Usually when you have a lot of dupacks, it just means you have a lot of latency between the client and the server. I had a lot of data in flight, and the client is just saying, great, thanks for all that new data. By the way, I'm still missing those sequence numbers back there, so get the hint. When you can get around to it, retransmit that. So that just means a lot of dupacks. It just means usually a lot of latency, or a good amount of latency between client and server. It doesn't mean the sky is falling. Typically, what you'll see is after the network round trip time, right? We saw a number like this in our previous handshake. Right around that amount of time is when you'll see a retransmission. Now, spurious retransmission, quick side point, I have a YouTube video about it, go watch it. Spurious retransmission just means this is retransmitted data that we have already seen an ACK for. It's spurious. Why are we retransmitting this? We've already seen an ACK for it. There's a handful of reasons for that, but the thing that I want to see, I start to see more dupacks, right? So that means this wasn't what we wanted to see. This could have been a retransmission of 8, 9, 10, 11. There's a handful of reasons we see that. Sometimes the ACKs go missing in the opposite direction. But anyway, I want to come down here, and when all of these ugly black lines clear out is down here, fast retransmission 1441. That's when we finally see segment 7, for example, finally get to the client, and now he's happy. No more dupacks. He's able to increase his acknowledgement number. We're good. Now we're solid. We finally retransmitted what was being asked for. Now, Chris, I had 108 dupacks. Is my network falling apart? No, you lost one packet and it took TCP 138 milliseconds to respond. Here's the question, people. Ready? Is this what you are troubleshooting? Is this what your users are punching their screens over? Can they handle 138 milliseconds of recovery? Probably. If this happened, your users likely, if it just happened once, your users weren't even aware of this. So take a chill pill. They didn't even know this happened. This is TCP recovering. The reason why I want you to know this is because I see people, especially when they're first getting used to WireShark and TCP, they go down these rabbit holes and follow these black lines to the nth, like find out all these details when really all we lost was 138 milliseconds. Is that really why they called us? Probably not. Why did they call us? Let me show you a trick before I go to questions. And I know I'm coming to the end of our webinar, so we'll keep moving. This might not have been what you were looking for. What were you looking for? Well, we can either sort delta. That's a good thing. We can sort delta. Let's come down to the bottom. What we're looking for is stuff like this, like larger delays, like 1.578 seconds. That doesn't sound good. 696 milliseconds. That doesn't sound good. Or better yet, I'm going to resort this, put this back in order. I'm going to remove my filter. And you know what I'm going to do is I'm going to add a column up here called TCP, and follow along with me, people. Pull up TCP, go down to timestamps, and I want to load time since previous frame in this TCP stream as a column. All right. Any TCP header, timestamps, time since previous frame in this TCP stream. I'm going to apply that as a column. Now you would think, oh, isn't that the same as delta time? And the truth is, no, it's not. This shows me time in context to that conversation between packets, where delta time just shows me time between packets that you physically see, which could have a lot of connections in parallel. All right, so now we're going to sort this guy. All right, going to let that sort. I'm going to jump down to the bottom. And now I start to see my pain points in a trace file. At one point in my trace, I have a 20-second gap. In fact, I have two of them. Above that, I've got 1, 2, 3, 4, 5 10-second delays with this server over here. So this is a quick way that you can set a filter and, hey, is this a server that you want to troubleshoot? Is this a server you want to troubleshoot? If this is, let's say, hey, someone's complaining and this is the server that is doing the pain. Well, right here, I just found 50 seconds of delay between my client and this server. That's something that I want to troubleshoot. Let's grab one of those. And I'm going to right click, put this in context, conversation filter, TCP. And I'm going to, again, remember to sort your number column, put everything back in line. Now, check me out. If I unclick this, by the way, mark unmarked packet, set unset time reference. This guy should go away, actually. There we go. Okay. So now check me out. I've got a 10-second delay where client asked for something, server came back, client asked for something else, and it took 10 seconds for that server to begin to respond. That's what you want to troubleshoot. That's the stuff you want to focus for. So TCP can help time this, but it's important not to get hung up on the black lines if they're not really causing you pain. These are the kind of things that cause you pain. So that type of issue. Now, right now, I'm going to cut over to questions. But before I completely wrap the content here, this stuff is very important to understand. That's why Dan and I, we've been talking about doing our workshop here, a WireShark workshop, and I think Dan's going to give us a bit more information about that. And in the workshop, we're going to be able to spend 4 hours together, unlike the 1 hour we had here. And even beyond that workshop, the virtual WireShark virtual training, where we spend 2 days doing this together, and we do exactly this. Here's a trace file. Let's get some hands-on. Let's ask some questions. Let's explore these different indicators and get a full understanding of what really matters with TCP when we're looking at it with WireShark. So with that said, I know you have some questions. So let me come down to those questions. I'm just going to stop sharing for a bit. And Dan, if you had any comments, feel free to jump on before I start jumping into these.
Yeah, just as a note, as you start scanning through the questions, one of the things I mentioned in the chat window is that we will be holding a 4-hour WireShark workshop in December. We're going to break that up into two-hour sessions in a given week. Chris and I are still working on getting the schedule set. As soon as we have that set and the registration links up and running, we will be sure and send an email out to you folks with information about how to register. As I hope you agree, Chris does an amazing job and is clearly has a tremendous skill around using WireShark, and he can blow through stuff pretty quickly in an hour. I hope that you're picking up some good tips and tricks. And there's a couple of questions that I think are going to help with that as well. But if you join this 4-hour workshop, be a little bit slower pace, everybody going to be able to follow along, go through the exercises, and hopefully you get some tremendous value out of that too. So I just wanted to mention that that's going to be coming up. So Chris, there are a few questions, and just to reemphasize, in the question section, and I think I also put it in the chat, there's a link to GoToStage. GoToStage is the GoToWebinars repository of recorded webcasts. And last week's webinar is there today, and today's webinar will be up there shortly. So with that, I'll let you get to the questions, Chris. Looks like there's a good one that you could pop in real quick. Show how to make that TCP segment length column again.
Sure.
Sounds like right-clicking is your friend in WireShark.
Absolutely. Yeah. Hopefully you caught me demonstrate that, because I did glance at that question. It's in the TCP header. You're going to see segment length, and that's where we rip off the Ethernet and IP payload, or the header stuff, and that just shows from TCP, the length from TCP up. Question about if a SAC is denied on a destination, will that deny the TCP handshake? So if I send a SYN with a SAC option, and the SYN-ACK comes back with no SAC option, does that kill the handshake? No, it just means we don't get to use that option. So now we're stuck. All those dupacks that you saw wouldn't happen. we would get stuck on packet 7 or sequence number 7. I would just keep asking for 7, and I wouldn't be able to acknowledge any data after 7. The stuff that I did receive, you would have to resend everything, even if I had already successfully received it. So SAC is really important to see on your connections. By the way, tip: watch out for no SACs on IoTs. We want to make sure Internet of Things devices. Those devices sometimes have weird stacks. Question: will the maximum segment size be 1460 max? And it's user defined. So 1460, if you think about it, 1460, as soon as you add the minimum TCP header that can happen is 20. 1460 plus 20, 1480. The minimum IP header is 20 bytes. So 1480 plus 20, 1500. So that's why a lot of times we're just trying to get under our MTUs. MTUs 1500 is pretty common to see. Add our 18 bytes of Ethernet frame, well, then you get your 1518 maximum frame size. So again, TCP is just trying to stay under the MTU up above. And that's one way that we can control that. Do you review layer 1 issues as well as cabling or even bandwidth issues causing slowness? So in the course, absolutely, we look at bandwidth issues causing slowness. I talk about what some layer 1 issues could be that you can go hunt for. So absolutely, when we see retransmissions, what caused a packet to be lost? Why would a network drop a packet? Yeah, for sure. Those are things that we're going to cover both in the workshop and in the extended virtual WireShark training. So Dan mentioned it, and I just want to say it again. Please keep in touch. Please reach out to me if you had any other questions about the webinar, chris@packetpioneer.com. I'm happy to help you. Stop by my YouTube channel. A lot of what we've covered today is out there with small, digestible videos. I apologize if I went too fast. I know I'm blowing a lot at you, but this also illustrates the importance of thoroughly understanding every single one of these concepts that I talked about today. So please come back for the workshop. Come back for some extended virtual WireShark training. And in the meantime, stop at my YouTube channel and keep on capturing people.
Hey, thanks, Chris. And hey, I just wanted to mention, it sounds like my audio cut out at the start of the webinar when I was doing your introduction or just before. The couple of things that I was pointing out, what you're seeing on your screen, and I think this is where my audio was cut out. One of the features that we've just released for the EtherScope and also available on the LinkRunner 10G instrument if you've got Ally Care support, we've got the Discovery app in EtherScope. In fact, I might as well just go over here and show you a little bit about Link Live. Hope this won't take too long, but Link Live is our cloud service to which you can claim your tester, your instrument, and then your test results are uploaded to the cloud. Another capability, I'm going to click this remote button. I'm establishing a connection with an EtherScope that's actually in a test network in our Colorado Springs engineering office. So I can actually connect to that tool remotely, and I can run any one of the tests remotely. I can run my auto test, which is what the screen was that you were looking for at just then. I can launch my Wi-Fi analysis. So I'm looking at that Wi-Fi network. I'm listening to what's happening in the air in our Colorado Springs office where this instrument is located. But another capability is this Discovery application. Now, Discovery utilizes a variety of techniques to go out and discover devices on our network and uses SNMP to derive the information that tells us what are the connection paths between those devices. We use that information now to create this topology map. So in addition to being able to take an instrument out and do wired and Wi-Fi troubleshooting, I can also discover that network, generate a map. I can also export that map to Visio. And this map is effectively color-coded too. For example, this device here, this AP, was exhibiting some problems. If I click into that, I can see that it's this one in particular experiencing some packet discards. And then I can view into the interfaces, get information about that device, all from interacting with it from the map. So great new capability. What's unique about this is that we are combining information that we discover through our network connection, so talking SNMP to the infrastructure, but we're also mapping the wireless network. As we observe traffic of clients talking to access points, those elements will appear on the map as well. So it's a combined Wi-Fi and wired network infrastructure mapping. So great new capability. Check it out on our website. The other capability that we recently launched was this Air Mapper site survey capability. This was the ability to do a site survey using the handheld tools. And effectively, this is another thing that I could actually do remotely, is to launch into site survey and utilize this the data gathered from the handheld tool to be able to generate Wi-Fi heat maps. So all in all, some pretty strong capabilities coming out. Our engineering team is constantly on the move to do new things. But with that, Chris, any last words?
No, I just wanted to thank everyone for stopping by, and just want to encourage everybody to keep on capturing and stay close to all of the channels we've shared with you. Let's keep in touch.
You bet. Thanks, folks. Thanks for attending. Have a good day.